So in this problem, Gwen exerts a 36 Newton horizontal force. Because she's exerting some kind of force, this is also my force applied, as she pulls a 52 Newton sled. So this is the weight of the sled across a cement sidewalk at constant speed. The constant speed part will help us determine some more givens for us. What is the coefficient of kinetic friction then? So this is my unknown. Coefficient of kinetic friction between the sidewalk and the metal sled runners. We're going to ignore air resistance then. So let's go ahead and put my givens up here. I'm given my force applied to be 36 newtons. We are given the weight, which is 52 newtons. Our unknown is coefficient of kinetic friction, so here's my unknown. Next, I'm going to draw my free body diagram so that we can see what does the constant speed do for us. Okay, I'm going to let the sled be represented by this dot over here. I'm going to let the direction for my force applied to be to the right then. So this is my sled. We know that she exerts a horizontal force. This is my applied force, and it's 36 newtons. We know that there's weight. Weight always points downward. So I'm going to point downward right here. Here's my weight. And it's 52 newtons. Now, because we're on a cement sidewalk and we're assuming that's perfectly horizontal, there is a normal force that's opposite in the direction of weight, but equal in magnitude then. So right here, this vector here is going to be my normal force, and it's going to be equal to 52 newtons then. And we also know we have to deal with a force of friction then. And because we're going to assume the sled is moving to the right, the force of friction is in the direction that's opposite to the object's motion then. So it has to point to the left. So we know we have force of friction then. All right. Notice it says it's moving at constant speed. What does that mean? It means that if we add all the forces in the horizontal direction, that means that we add force applied plus my force of friction, it should equal to 0 then. So that means that my force of friction in this case has to be equal in magnitude but opposite direction. So it's going to be 36 newtons then. So based on our diagram, we know we have two more givens. The normal force, which is 52 newtons, and we know the force of friction then. The force of friction is going to be 36 newtons. So for this problem, there is only one equation that we could use to find the coefficient of kinetic friction, and it's this one right here. The force of friction is equal to the normal force times the coefficient of kinetic friction. All right, so let's go ahead and rewrite this again, and I'll go ahead and solve for my unknown. And in this case, my unknown is right here. So that means to get this by itself, I'm going to divide both sides by the normal force. So divide by normal force, divide by normal force. This cancels right here. I'll be left with coefficient of kinetic friction is equal to the force of friction divided by the normal force then. So with my force of friction divided by the normal force, I get that equal to the coefficient of kinetic friction. I'll go ahead and plug in my two values. My force of friction, it was 36 newtons. My normal force is considered to be 52. Set that equal to coefficient. Go ahead and solve for it. Just let 36 divide by 52. I should get 0.692 is equal to coefficient of kinetic friction. Just to double check that I got the correct answer, first you have to remember that there are no units on this, so I should not see any units here. Second point is notice that this is a positive number, it's not negative. You should not get any negative coefficient of kinetic friction values. And finally, the third point is that the answer that you should get should be a really small number. In our case, it's less than 1, so it does seem reasonable that this is our answer then.